My name's Timothy Young. I'm the Vice President of Mechanical Engineering for Liquid Robotics. We're a company that builds ocean-going sensor platforms. They're completely wave-powered. They're persistent platforms that can operate into the ocean up to a year at a time, carrying all kinds of different sensor platforms. To kind of plagiarize a little bit from our CEO, Bill Vass, he was asked by a reporter, why did he come to work at Liquid Robotics? And he says, well, these guys have designed the wheel for the ocean. And he said, can you imagine having a patent on the wheel? Yeah.
So this is a dry housing.
In the past, as far as for designing our vehicles, we've taken the steps of actually concepting, designing, building prototypes, and then testing, and then iterating on those concepts to actually get to where we are today. We learned a lot, but it's expensive and it's time-consuming. In the times that we are now and how we're trying to innovate as quickly as we are, that becomes difficult to have life cycles that are that long to be able to take the time to get that done. In the initial design phase of developing the vehicle, it was kind of interesting. We had some constraints that we don't have today. The problem was you can only do one thing. Say if we wanted to do some mechanical design, well then we could use a software package to do mechanical design. But if we wanted to do some computational modeling or run, for example, a fast Fourier transform of some acoustic data, when we would run some of these simulations, it would end up being that we'd actually start these simulations at the end of the day and let them run overnight. The problem with that, if you ever set up a complicated model, if you don't get it exactly right, it's not going to run. And so inevitably what would happen is it would crash during the night, and we lost a lot of time that way because we're still doing design. We wait till the end of the night again, and then we would run again. And now that we've switched to HP workstations with NVIDIA Maximus, we have a lot more computational power in a relatively small package.
Do you have the drag going out all the way to 90 degrees?
Now we can actually run ANSYS, SolidWorks, MATLAB all at the same time and be able to check on them throughout the day as they're doing computational analysis and still be able to get done what we were doing in the past from a mechanical design standpoint. In the past, we had a design failure of a spring in heavy conditions, and we wanted to design a new spring so that we could overcome those sea conditions. And when you have a system like Maximus, you can actually offload the computational analysis and still use the graphics card to do the mechanical design. Effectively, we had a spring that was failing at roughly 2 to 250,000 cycles, and actually this Friday it should be at 2.5 million cycles, so a magnitude better in performance. The hope is that from doing computational modeling, we do a lot fewer prototypes, and in the end, we want to do design that's first time right. So we want to use the computational modeling to its fullest benefit, and then from there, we want to build one prototype and test it as if it's the final product. Anytime that you can reduce a design cycle that's less manpower, that means that's a money saving to the company and to the customers. Today, that's a real game changer.